Hi, I'm George. I'm working as a software engineer at arconsis with experience across backend development, data platforms, and AI engineering projects. What I'm about to show you in this video is a multi-agent workflow we built at arconsis. The goal was to answer one question. Can AI agents actually help build a real production code base and produce code you can review and trust? Let's start with our initial problem and then deep dive into our proposed solution. Here is a prompt every team has tried. Claude, build the favorites feature. One sentence in, you get a wall of code. Entity, service, endpoint, it all looks reasonable, and it merges. But look at what was never checked. Transactional annotation is missing on the delete path, so a concurrent write can silently no op. Serializable annotation is missing on the DTOs, so every endpoint returns a 500. There are no tests, and if anything had interrupted that conversation, the whole context would have been lost. No plan, no reviewer, no verified build, no rollback point. That's the gap we want to close. The fix isn't a better prompt, it's a state machine. One command, /feature add favorite, kicks off a deterministic pipeline. The architect writes a plan and a state file. A reviewer signs off on the plan before any code is written. Then its implementation flows through the same loop. An author writes it, the build verifies it, the reviewer audits it, and only then does it become a commit. At the end, a final integration review checks the full branch, and /verify runs the real CI gate, the only signal we accept as done. Every change reviewed, every step auditable, and because state lives on disk, the whole thing is resumable from any interruption. 7 specialist agents, each one owns exactly one thing. The architect plans, it never writes production code. The code reviewer audits in 3 modes and never edits. In between, 5 authors do the actual work. 1 for the backend, 1 for the shared DTOs, 1 for the API client layer, 1 for the UI, and 1 dedicated tester. This is a recording of the real add favorites feature being built. 7 slices in dependency order. The first one, the backend domain, has just been dispatched. What's the right pain? The reviewer just rejected the first slice. Missing transactional annotation on the delete path, exactly the bug a one-shot prompt could have merged. The pipeline doesn't get to skip it. The author is re-dispatched to fix it. Fixed, verified, reviewed again, and committed. That's our checkpoint. If the whole machine crashes here, /implement resumes from this exact state next time. A test build just failed. Same loop, redispatch, fix, re-verify. 7 slices, 7 checkpoints. 1 reviewer code bug. 1 build feature auto-fix. 23 tests written along the way. And the final integration review approved the full branch before merge. Everything you just watched left a paper trail on the disk. PlanMD is the architect's blueprint, the same one the reviewer signed off. State.json is the machine-readable lifecycle of every slice, including the commit hash. ReviewMD is the final integration verdict. 6 months from now, someone who wasn't in the room can read these 3 files and understand exactly what shipped, why, and who or what approved each step. 1 feature by the numbers, 7 specialist agents, 7 auditable checkpoints, 23 tests, 1 critical bug caught before merge, 0 lost context across the whole run, 1 pull request, fully reviewed, merge green. Being honest about what this doesn't do is what makes the rest trustworthy. The framework automates everything inside the application: migrations, endpoints, TTOs, API clients, the UI, and every review along the way. It deliberately stays out of iOS native code, secrets, and CI configuration. When the architect detects an out-of-scope request, it stops and asks, by design. Silent guessing on those areas is exactly the failure mode this whole framework exists to prevent. The entire framework is 6 commands inside Claude code. Feature kicks off the full pipeline for a new feature. Implement resumes from state JSON after any interruption. Review, verify, check, and migration complete our toolset. 6 commands, 3 hooks, built on the Cloud Code Agent framework. That's the whole interface. To sum up, we don't claim this is 10 times faster. We claim that it's shippable without the cleanup pass that usually follows AI-generated code. Thanks for watching and remember to subscribe.